Hi, I'm Colin Walls, and today what I want to talk about is multi-core systems, devices with multiple CPUs. I'm going to look at it from the embedded software point of view, of course. Now, there are broadly two architectures from the software perspective for multi-core systems. The simpler one, I suppose, is symmetrical multiprocessing. This is when you have a device which has multiple cores and all the same architecture. And what you do is you run a single operating system across all of the cores. That's in fact the way your desktop computer probably works. Windows or Linux or whatever will run in SMP mode. The objective here is to simply use the multiple cores to produce more computing power to do whatever it is you want to do. And the operating system will take charge of distributing the activity across the cores. So that's SMP. A more interesting and somewhat more complex architecture is asymmetric multiprocessing, AMP. Now here, instead of running one operating system across all the cores, we run separate software on each core. This might be an operating system, it might be no operating system, and on a given device, you might have multiple different operating systems. The beauty of AMP is it lets you take each processor, which may be of different architecture from the others, and use it in an optimal way. So you can choose the right CPU architecture for the task in hand and give it the right operating system for that job. Now, AMP is a little more complex because you have to marshal it and control it, but nevertheless, it does give you that extra flexibility. So we're seeing an increasing number of heterogeneous multi-core devices which we can use in AMP mode on the market today, and that's a common way of developing complex embedded systems. To make it more interesting, you could actually combine the two. You could have a system where multiple cores are grouped together as an SMP system, and there's several of those across the chip. And therefore, collectively, they form an AMP system. Interesting idea, isn't it? Fairly complex, but there must be applications where you need to marshal multiple CPUs to get CPU power and others to get specialized functionality. So that's just a little introduction to what Multicore is all about. There are lots of other topics to cover which we'll look at on future occasions. But for now, thanks for listening. Bye for now.